Before even telling you what this video is about, just take a look at how this V-bit works in oak and in ash. Today I'm going to show you how to make V-Carve Inlays using Blender and the add-on that I'm using for generating G-code for my CNC in Blender, which is called FabEX CNC. Why did I choose to show you how to make V-Carve Inlays? Because they have some advantages. The first advantage is the fact that you will get very crisp, very sharp details, because all the corners will have a radius equal to the diameter of the tip of the toolbit. This is great for small details, it's great for corners, it's great for lettering, and there is another reason for which V-Carve Inlays are much better. The slight taper of the walls, depending of course on the toolbit, in my situation a 30 degrees toolbit, the slight taper on the walls help you match the two pieces together without having to hammer them into place, without having to leave too much tolerances. Everything will fit almost perfectly every time. I will show you how to turn an SVG into such a V-Carve inlay, how to make the two parts. I will show you what is important to know about how to set things up, adjust the tolerances, so after a few testing you will know how to make a V-Carve inlay on your machine in just a couple of minutes. Before moving on to showing you the first part, how I create the G-code for the base, for the pocket in the base, let me thank everybody for supporting me by subscribing to my channel, by commenting, by giving me feedback, and of course a very special thanks to all the people that support me through my Patreon page. And if you want to be part of the people that support me through my page, you can find the link in the description of the video. I'm using Blender 4.5 and the latest version of FabEX CNC. If you want to know how to install the add-on into Blender 4.5, you have this video here. It's about Blender 4.3, but it works exactly the same also in 4.5. Now let's start. I will create a new general file. And the first thing that I'm going to do is import the logo. For that, I will go to File, Import, Scalable Vector Graphics, go to the folder where I have the logo, select it and click on Import SVG. Depending on the quality of the SVG, you might have to make some adjustments, but the SVG that I'm using is pretty well made. Let's now turn it into a V-Carve toolpath, both for the pocket and for the object that we are going to insert into that slot. Before starting to actually create the operations, let's press N to open the side menu, go to Item, and let's set a dimension. I will set the dimensions to 300 by 300 millimeters. Now the logo is correctly scaled. I will also move it 1 centimeter to the left and upwards to avoid these letters going all the way to the edge. So let's set X to 10 and Y to 10 millimeters. Now from this menu I'm going to select Intarsion. Remember, I have to have the object selected, the logo, the SVG that I have imported. Click on Intarsion and let's make some settings. The cutter diameter is going to be 0.2 millimeters. That is the diameter of the tip of the V-Carve toolbit. This is a great advantage of the V-Carve type of inlays. You will have corners equal to the radius of the tip. The cutter tolerance should be as small as possible. It's 0.05 here, but I will set it to 0.02. And everything will be just as is. I don't need these settings, they are very useful and I will explain them in another video, but these are the only two settings that we are going to use. Now let's click OK to create the two objects that we need, which are the Intarsion pocket and the Intarsion profile. You can sort of see them highlighted in the 3D view, so let's hide the object that we have imported. These are the two objects that we are going to use to create the toolpath. We are first going to set up the pocket, so I will hide the profile for now. You can now see the pocket, it looks exactly as it should. Let's go to the render tab, and here from the render engine that is default, I will change it to FabEX CNC render engine. In order to get this pocket, I will have to set up two operations. One to mill the edges, where I will use a slower speed because I want to avoid the wood grain being teared apart. And then I will use another operation to mill to remove all the material in the center of the object. So let's scroll down to operations, click on the plus tab, but just a small reminder before going to that part. If you haven't used FabEX CNC until now, go to the machine tab and select the proper post processor, the proper unit system. Let me just enlarge this a little bit. I'm using metric and millimeters. Set the work area, because if the work area is not set correctly, you will end up with some errors. Set the feed rate, the default feed rate, the minimum and the maximum. These are very important because any feed rate that you set when creating an operation, if they are larger or smaller than this feed rate set here in the machine, they will automatically be reduced to this value. The same applies for the spindle speed. So set the correct spindle minimum and maximum speed so you can set everything up correctly in the operations. Now let's scroll a little bit up to the operations tab, and here I have this plus button. Make sure the object is selected, the proper object, the pocket, and now let's click on the plus button. Let's go to the CNC tab to set things up. The first thing we need to do is change the strategy from profile to medial axis. This is the way V-Carve is called in Blender. I will leave the settings, the default settings, just as they are. They are pretty okay for almost any job. Make sure the add pocket option is checked. This will create another object with the area that needs to be removed after milling the edges of the object. I will show you just a couple of minutes how you do that separately, but group them together in a single file. Since my object is going to be placed on the CNC table and I'm going to set the Z0 on the top face of the object, I will use a safe height of just 2 millimeters because I want to avoid as much as possible useless up and down movement. Let's set the depth that I want to cut. I've decided to use a 3 millimeters depth for the pocket and of course for the inlay, so I want to set the operation depth to 3 millimeters. Go to the max value, change to custom and set an operation depth of -3 millimeters, -3 because I remind you, I've set the Z0 on the top face of the material. I'm not going to use layers because since I'm only milling 3 millimeters, the toolbit that I'm using is pretty good at it. So I don't need to use any layers, everything will be a little bit faster. Scrolling lower, the next section is the cutter section. Let's change the type to V-Carve, the angle to 30 degrees. This is what I'm using, of course. If you're using a different toolbit, set the angle according to the specifications of your toolbit. Let's change the diameter to 6.35 millimeters. This is because the toolbit that I'm using is in inches. A quarter of an inch equals to approximately 6.35 millimeters. The next section is the feed rate, where I'll set a value of 2000 millimeters per minute and a spindle speed of 21,000 RPM. I'm using a low feed rate and a high RPM because, as I've told you earlier, I want to avoid any chip out on the corners on the small objects. So setting a smaller speed rate and a higher spindle speed should avoid those problems. The plunge speed, which is the speed on the vertical axis, on the Z-axis, is represented in Blender as a percent of the feed rate that I've set earlier for X and Y. I will use a 100% value. My machine can handle it. If your machine has a weaker Z-axis, set a lower speed and everything should be okay. One of the most important things that I want to remind you to never forget to set up is the output trailer. Check this field and write here M02. What does this do? This stops the machine after the operation is complete. Otherwise, you will end up with a machine that will keep on spinning and you have to manually stop everything. It's pretty annoying, so remember, check output trailer and write M02 here. In the movement type, I won't change anything. The cutter spin is correct. This is the way my spindle spins clockwise. Most of the spindles should spin clockwise. The milling type, I will leave it to climb, even though conventional should end up with a slightly better result. Again, the same problem. Chipping on the corners might occur more frequent when using a conventional cut, so I will leave it as climb. There's nothing else that I need to set here. All the default values are okay. I can now go back to the right panel and click on Calculate Path and Export G-Code. Don't get fooled by that name, it doesn't export any G-code because I haven't set a file name, I haven't saved the file that I'm working in. I will show you after calculating the toolpath how to do that. A few things happened. First, I have the lines on the screen that represent the toolpath. I can select it from the right CAM path. You can see each of the operations creates an object which has a prefix of CAM path, so it's easier to find them in the tree. If I click on it, you can see it highlighted. It's 3 millimeters lower than the drawing and it's set to the inside, so the toolbit will run exactly along the edges of the design. Two more things have been created. One is the Medial Pocket. You can see it here. If I turn on the visibility of the CAM toolpath, you will also see the pocket, which is exactly where the cutter passed. This is a curve that represents all the area that still needs to be removed in order to get the correct shape in the end. When clicking the calculate path for the Intarsion pocket operation, it also created a medial pocket operation, which I'm going to rename. But first, let's rename the medial pocket up here. Press F2 and I will call it Medial Pocket Inside. Now let's also rename the operation. I cannot press F2, but I have to change it from here from operation name. I will also change the file name. Now let's set up the operation. Let's scroll back up to the top of the tabs in the CNC panel. If you don't have this panel here, I remind you pressing N toggles its visibility. Since I want to remove all the material, I will leave the strategy as pocket, change the type from perimeter to parallel. This will be a little bit faster and, most important, better. Change the angle to 90 degrees or to 0 degrees depending on how you want to move it. You can even leave it at any angle. It's just the angle which will be used for making the cross hatch. The hatching, not the cross hatching. I've wrongly read cross hatch because I have it here on the screen. I'm not going to use it. I don't need that type of precision. But I will check the contour finish so I have another pass close to the line that has already been milled. For V-bit, a step over of 1 mm is a little bit too high, so I will use a value of 0.4 mm. This should leave a surface smooth enough so I won't have any problems when connecting the two pieces together. Again, let's change the safe height from 10 mm to 2 mm. This should be enough. And for the operation depth, I can repeat the process that I've used for the initial milling, but if I take a look, I can see that this pocket has automatically been created at the height that the previous operation used. So I can leave it with the default values, the max depth from object, or, as I've told you, set custom, set -3 mm, and I'm good to go. Again, I won't use any layers, I don't need layers. Let's set the cutter to V-Carve, the same angle, 30 degrees. And here is the trick that you need to know in order to get correct results. Instead of setting the diameter of the entire toolbit, you'll have to use the diameter of the tooltip, which is 0.2 mm. Of course, you'll get a warning of high engagement, but this won't be a problem because all the areas have already been milled. Set a field rate of 3000 RPM this time and a spindle speed of 20,000. Again, a plunge speed of 100%. This time I can use higher feed rates because the material that I'm going to mill is just left over in the center of the pockets. I don't care if grain will crack, pieces will break, since all the edges have already been milled and the cutter won't touch them anymore. Again, check the output trailer. Now I really need to change something here, the milling type from climb to meander. If I don't do that, I will end up with a at least double milling time because the cutter will only cut in one direction, then it will lift up, go back to the starting point and so on. I want it to mill on both type of movements because, as I've told you, I don't really care about the quality on the sides, just the bottom face. Leave everything just as is. Click on the calculate path and export G-code button. But as you can see, I cannot do that. And there's a reason for that. Scroll a little bit down, you can see that the object is highlighted in red because I've changed its name. Click here, select the medial pocket inside object, and now everything is okay. I can click on the calculate path and export G-code button. Now you can see that I have the toolpath created for the pockets to remove all the material that remained after the first operation. It takes a little bit of time, 23 minutes, but for a logo this size, I don't think it's a problem. If you want to know how to make this a lot faster using a different toolbit, let me know in the comments. And I will gladly update the video, create a new video with the updated version to use a different toolbit for removing all the material, but still preserving the sharp corners and everything that I need to preserve here. Now let me explain to you how to export this G-code, how to export the G-code for the inlay, for the negative part. So let's go to the chains group and click on the plus button to create a new chain. Then select the first operation, click on the plus button in the second group of the chains. So here I have the list of chains and here I have the list of operations in each of the chains. So select the first operation, click on the plus button in the second box. Now do the same with the medial pocket, click on the plus button, select the first operation, go back here to operation G-code and uncheck the output trail. Why is that? Because since these two operations will be in a single file, I don't want the machine to stop. I just want it to continue to run everything up to the end. Now let's calculate the chain path again, just to make sure everything will be calculated correctly. Even though I have an error, I don't really care about it. Let me explain why it happened, why it showed up, and how to remove everything that was created. You remember that after creating the first operation, it created an object called Medial Pocket. We've renamed it to Inside. Now it recreated that object, but it renamed it to Medial Pocket again. So let's rename it again, Medial Pocket Inside. It also created a new operation, Medial Pocket, which we can delete without any worries. Click on the minus button after selecting it here in the operations group. And now everything should be just fine. For exporting the file, I need to do one more thing, which is save the Blender file. If you don't do that, you will have trouble locating the G-code file. So let's go to File, Save this Blender file. Anyway, it's a good practice to do that. So, crafted path logo, V-Carve Inlay. And now that the file is saved, I can click on the Export Chain G-code, which will generate the G-code file in the same folder. Now let's take a look at how the machine is performing in Ash, and then I'm going to show you how to create the G-code to make the positive part, the one that is going to fit into the pocket that we've made in the first part. And in case you're asking yourself what's this Crafted Path Studio logo, well, it's another channel that I'm starting right now, which is going to focus mainly on the machine milling stuff. And let me tell you that this is the last time that I'm going to make a V-Carve Inlay using only the V-bit. This part took more than 1 hour, a lot more than 1 hour, and I understood why the time estimation in a lot of programs doesn't match the time that it actually takes on the machine to make. It is because in the program, when you have small movements from left to right, it will calculate all those movements using the feed speed that you have set. But the machine needs to accelerate and to decelerate, so it will go a little slower than what the program calculates. All those small movements will add up and you will end up with a file that takes longer to mill than what you expect. I won't make any V-Carve Inlay using just the V-bit. I will only make the outlines using it, and then I will use an hand mill to remove most of the material much quicker. So now that we have created and milled the inside pocket, we need to make the positive part, the one that is going to fit into that pocket. Let me hide all the things that we are not going to need. I'm going to turn on the visibility for the Intarsion profile. The first thing that I'm going to do is select it, press the Tab key to enter edit mode or switch it from here, and go to Add Menu, select Rectangle. And I will give it a width of 320 millimeters, the same for the length. And then I can click on the title of this box. Now let's position it, go to the Item menu and set an X and a Y of 160 millimeters on both axes. Press Tab again to exit edit mode Now you can see that the object transformed into a negative for what we have already milled. But we still need to do something. Let's go to the object menu, to the mirror option and select X global. Now let's change the X again to 320 because when flipping it, it moved in the negative side. I have the object ready, correctly positioned. We can now start creating the toolpath. We will do exactly the same as we did for the inside pocket. We will do the same for the outside pocket. So let's select the object, go to the operations group, click on the plus button, and I have an up Intarsion profile. Let's go to the CNC tab and change the strategy to Medial Axis. Also leave the add pocket checked. Let's change the safe height to 2 millimeters and set a custom operation depth of -3 millimeters. But before continuing, I want to mention something that is really important if you're using a different toolbit, a different machine. I've used here an operation depth start of 0 millimeters, which for my setup for a final depth of 3 millimeters works okay, but that is because there are some tolerances. The normal value for the start operation depth is always half of the operation final depth. So normally I would use here a -1.5 millimeters value, and that would result in a perfectly fitting inlay. Because you never have a perfect setup, you have to play with this number. I ended up with a value of 0 for a -3 millimeters. For example, when I'm making an inlay with a -10 millimeters operation depth, I'm using a start of -4, so it's not really half of that value. You have to adjust it a little bit, but generally a value with 1 millimeter less than a half should work. In my case, it would be -0.5 millimeters, but I ended up using 0 millimeters because that appeared to work okay for this particular situation. But remember, the operation depth start should be half of the operation final depth. I will uncheck layers, change the toolbit to V-Carve, and set a diameter of 6.35 millimeters. I almost forgot the V-Carve angle. Set it to 30 degrees, otherwise everything will be a mess. Let's change the feed rate to 2000 millimeters per minute and the spindle speed of 20,000 RPM. Also, let's change the plunge speed to 100% and check the output trailer. Make sure there's an M02 command here. Leave the milling type and the cutter spin clockwise, as this is the way my machine works. Now I can calculate the path. And after calculating it, I will also have the pocket for removing all the material around the logo. The toolpath is ready. If I rotate the view, I can see it at -3. Everything seems exactly as it should be. Let's rename the Medial Pocket, which you'll be able to see here. It's the material that we need to remove. Let's rename it by pressing F2 and call it Medial Pocket Outside. And let's also rename the operation. And now let's make the settings for this operation. Let's scroll back up, leave the strategy as is. Pocket, change the type perimeter to parallel, set an angle of 90 degrees, and check the contour finish. I will use a step over of 0.4 millimeters, a safe height of 2 millimeters, and again an operation depth set to custom to -3. I won't use any layers as the thickness, the depth of cut is pretty small, it's just 3 millimeters. What I have to do is change the cutter type to V-Carve, 30 degrees, and the diameter of 0.2 millimeters. Of course, I will have this warning of high cutter engagement, but it's basically a hack what I'm doing here. It doesn't really matter, it works, and that's the most important part. Let's set a feed rate of 3,500 millimeters per minute and the spindle speed of 20,000 RPM. Also change the plunge speed to 100% and check the output trigger. As we did with the previous removal of material, let's change the milling type from climb to meander zigzag so we save half of the time so the cutter doesn't lift, go back to the starting position, and so on. That's all we need to set. As you can see, we have an estimated time of 0 hours and 54 minutes, together with a profile which takes 5 minutes, somewhere around an hour, and we will have this part ready. What we still need to do is to create a new chain, so let's go back up here, click on the plus button to create a new chain, and now let's select the two operations, click on the plus button in the second box of the chain, select the last operation, click the plus button again, and now we're gonna export the chain G-code. But before exporting the G-code, I still need to do something. Go to the Intarsion profile and uncheck the output trailer so the spindle won't stop after the first operation. You can leave it like that, it will just stop, and when starting the second operation it will turn on again. It depends on the preferences and if you want to recalculate everything again. So I uncheck the output trailer for the first part, recalculate the path, and then export the chain G-code. That is all you need to do to make the two parts. Now let's fit them together and see how everything turns out in the end. If you want more information about how I create the toolpaths to clear everything, to remove the extra material, let me know in the comments and I will make a special video exactly about that, because there are a lot of things that you can set, a lot of ways you can do things, and I think it's pretty important to have the time to talk about all of them.